Hi, in this video we are going to solve this question of Cauchy's integral formula and Cauchy's theorem. So the question is if f of zeta is equal to integration of 4z square plus z plus 5 upon z minus zeta with respect to z along the curve C, where C is the ellipse x by 2 whole square plus y by 3 whole square is equal to 1. Then we have to find out the values of f of 3.5, and then next we have to find out values of f of I, f dash of minus 1 and f double dash of minus I. So first we analyze the curve. Since the equation of the curve is x by 2 whole square plus y by 3 whole square is equal to 1. So as we can see in the figure, this is the ellipse x by 2 whole square plus y by 3 whole square is equal to 1. Now the first value we have to evaluate is f of 3.5. So in place of zeta we put the value of 3.5 in the integral. So now our integral is integral around the curve C, where C is the ellipse, and f of z is 4z square plus z plus 5 upon z minus 3.5. And now to find pole, we put the denominator is equal to 0. So when we put the denominator is equal to 0, the value of the pole is 3.5. Now we check whether the pole is inside or outside. So 3.5, z is equal to 3.5. As we can see, it is outside the curve C. Therefore, since the pole is the outside pole, therefore the whole function is analytic within the curve. Therefore we can use Cauchy's theorem, and Cauchy's theorem says that if the fz is analytic within any curve, then integration of fz dz is equal to 0. Therefore integration of 4z square plus z plus 5 upon z minus 3.5 is equal to 0. Hence the value of f of 3.5 is equal to 0. Next we have to evaluate some more values. Since f of zeta is equal to integration of 4z square plus z plus 5 upon z minus zeta dz along the curve C, where C is the given ellipse. Now we have 3 points I, minus 1 and minus I. We can see that the other points I, minus 1 and minus I, all the 3 points belongs to the curve C. All the points are inside the curve C. Therefore we use Cauchy's integral formula. So Cauchy's integral formula says that g of a is equal to 1 upon 2 pi I integration along the closed curve C gz upon z minus a dz, where g of z means the numerator. So in this question the value of g of z will be 4z square plus z plus 5. So to evaluate the integration of gz upon z minus a dz, the value of this integral will be 2 pi I into g of a. Now if we compare with the given question, the value of gz will be 4z square plus z plus 5, and z minus a will be z minus zeta. So in place of a we have to put zeta. Therefore its value will be 2 pi I into g of a. That means g of, in place of a we have to put zeta, so it will be g of zeta, and g of z was 4z square plus z plus 5. Therefore g of zeta will be 4 zeta square plus zeta plus 5. Therefore the value of this integration, which is equal to f of zeta, will be equal to 2 pi I into g of zeta, that is 2 pi I into 4 zeta square plus zeta plus 5. So this is the value of f of zeta. Now if we differentiate both sides with respect to zeta, the value of f dash zeta will be 2 pi I into differentiation of right hand side with respect to zeta will be 8 zeta plus 1 into 2 pi I. And if we again differentiate it, it will be f double dash zeta is equal to 16 pi I. Now, since we have to find out the value of f of I, so this is the value of f of zeta. So in place of zeta, if we put I, f of I will be 2 pi I into 4 I square plus I plus 5. Since we know that the value of I or iota square is minus 1, so it will be 2 pi I into minus 4 plus I plus 5. So finally it will be 2 pi I into I plus 1. So this is the value of f of I. Our next value was f dash of minus 1. So this is the value of f dash zeta, which is equal to 2 pi I into 8 zeta plus 1. So in place of zeta, if we put minus 1, the value of f dash of minus 1 will be 2 pi I into minus 8 plus 1, which is equal to minus 7 into 2 pi I, which is equal to minus 4 pi I. Now, since the value of f double dash of zeta will be 16 pi I, so if we have to find out f double dash of minus I, so we put the value of zeta as minus I, and since the right hand side is constant, it is free from zeta, therefore the value of f double dash of minus I is equal to 16 pi I. So we have found all the values. So this is the question. Thank you.